Okay, so here we go with another revision example, and let's take a look at this one. So, number 2, suppose the universal set is all x's, um, now we're only taking into account our positive integers, and less or equal than 12. A is multiples of 3, which are less or equal than 12 as well. Letter A, show A on a Venn diagram. Well, what are the multiples of 3? So we're only considering positive numbers, right? So multiples of 3, well, 3, 6, 9, 12, and there you go, because that's our limit, our topmost number. So 3, 6, 9, and 12. So draw a Venn diagram. So this is our universal set. Let's call this A. Let's just populate this. So inside of my set, I've got 3, 6, 9, and 12. And outside, everything else which I have in my universal set. So what are the numbers which are positive, less than 12, and are not in this set? So 1, 2, 4, 5, 7, 8, 10, and 11. Right? And obviously, if this is A, this here would be complement of A. What's outside of A is the complement of A. And that brings us to the second question. List set complement of A. So what's A prime? Well, it's everything which is outside. It's everything which is in this set, but not those. So what we have in our universal set which is not in set A? 1, 2, 4, 5, 7, 8, 10, and 11. So those are the elements of our complement of A. What is the number of elements in our complement of A? So number of elements, we just count. 1, 2, 3, 4, 5, 6, 7, 8. Just for fun, what would be the number of elements of set A? It's 4. And what's the number of the elements in the universal set? 12. It's not an accident that those add up to this, because all of the elements which are not here, they will be here, right? So anyway, letter D, true or false? If C is 1, 2, 4, C is a subset of A. Well, it's quite obvious that C is not a subset of A, simply because if you look at A, 3, 6, 9, and 12, if C is 1, 2, and 4, none of those elements are in here. C would, however, be a subset of complement of A.